Hi, we're back in our notes for solving polynomials with example 3. And here we've got just the equation given. They haven't given us any factors, haven't given us any graph to look at. So we're going to need to create our own graph using graphing technology to find some rational zeros to start our synthetic division. So if you go to your y equals in the graphing calculator, then we're going to type in the function negative x to the 4th power and then plus x to the 3rd power minus 7x squared plus 9x plus 18. And then zoom 6 gets us a standard negative 10 to 10 viewing window, and we can see that the graph is appearing to cross at -1 and at +2. If you press trace and then type in x equals -1, if we get back y equals 0, which we do, then we know that that is a real zero. And same thing for +2. If we trace with +2, press enter, we get a y equals 0. So I can see that those two zeros are on the graph, and I can use those then for my synthetic division. So in the notes, that is what is pictured here. Right? We've got a picture of the graph where it is crossing here at x equals +2, and there's also a cross on this side at x equals -1. Right? Those values can be verified looking at the table of ordered pairs. There's my -1 and my +2, if you can't tell from tracing on the graph. So in step number 1, right, we graph to find the rational zeros. Step 2 now is to do synthetic division with one of those zeros. So I'm going to choose to start with x equals -1, but you could use x equals 2 first instead. It doesn't matter which order you go in. So I'm going to put my -1 out front and then list my coefficients on the polynomial. So -1 is my coefficient on x to the 4th. +1 is a coefficient on x cubed. And then there's -7x squareds, 9 x's, and the constant is 18. So I bring down my first value and then multiply. -1 times -1 is +1, and add 1 plus 1 is 2. Then multiply. 2 times -1 is -2, and add -7 plus -2 is -9. Multiply. -9 times -1 is +9. Add 9 plus 9 is 18. Then multiply. 18 times -1 is -18, and add 18 plus -18 is 0, and that 0 is the remainder. So I know that x plus 1 was a factor of my polynomial. And then I'm going to repeat now synthetic division with my x equals 2, 0. So I'm going to have a 2 out front. Bring my bar across, stopping at the constant. Bring down that first term of -1, and then multiply. -1 times 2 is -2, and add 2 plus -2 is 0. Multiply. 0 times 2 is 0, and add -9 plus 0 is -9. Multiply. -9 times 2 is -18, and add 18 plus -18 is 0, and there is the remainder of my second division. Okay, those were the only two real roots that we could see on the graph. So this quotient, I'm going to write out my remainder is the last, then the constant is -9. The x has a coefficient of 0, and then -1 is the coefficient on the x squared. So since my remainder here was 0, I know that x minus 2, the divisor, is a factor, along with my quotient, -x squared minus 9. And that would be my completely factored form. Okay, then my last step after writing in factored form, I want to set each factor equal to 0 and solve for x. So x equals -1, that was a 0 we saw on the graph. X equals +2, that's a 0 we saw on the graph. But this quadratic factor here, -x² - 9 equals 0, I'm going to solve that for x by adding 9 to both sides. Solve -x² equals 9. Then I'm going to divide both sides by -1. X² equals -9. Then to undo a square, we use the inverse operation, which is to square root, and x then is equal to ±3i, because the square root of -1 is the imaginary number I, and the square root of 9 is 3. So that would be 2 zeros, 3i and a -3i. So my final answer then would be x is equal to -1, +2, and then ±3i. And that would be 1, 2, 3, 4 real zeros. And when I compare that to the degree of my polynomial, which is 4, they're all accounted for. So remember, the fundamental theorem of algebra says the number of zeros, complex zeros, has to match the degree.